Good day, everyone. I'm Dr. Jahanian with another problem, which this problem is very similar to the Olympiad problems, which I think that if anybody can solve this particular problem, yet turn this impossible to possible, because when you look at the problem first, it seems it is impossible to be able to solve this problem. But um, when I tell you how to solve it, you'll see that how we turn it impossible to possible. This was given at Japan's mathematical Olympiad, and the problem which we have is that if n is equal to n times n plus 1 times n plus 2 plus n times n plus 3 plus 1, and n is an integer, how many natural number less than 1000 exist such that if n is divisible to 25? First, what I'm going to do, I'm going to have review some terms for benefit of my uninitiated audiences. If you familiar with these terms, you can fast forward the video and watch the solution of the problem. So let's first review some of these things. The first thing which I'm going to define is the real number, and I took this directly from the Wikipedia. In mathematics, a real number is a number that can be used to measure a continuous one-dimensional quantity, such as a distance, duration, temperature, and so forth. Here, continuous means that a pair of value can be arbitrary, can have arbitrary small differences. It could be a rational number, such as integer minus 2, 0, or 1, fractional number, such as 1/2, 2/2, and irrational numbers, such as pi, 22/7, and so forth. Natural number, on the other hand, which again I took it from Wikipedia, in mathematics, natural number is the numbers such as 0, 1, 2, 3, etc. Some author believe 0 should not be part of natural number. Some author, on the other hand, believe it should be part of that. But in this particular problem, really 0 is not part of the natural number when we refer to natural number. A symbol which we use for natural number is n, and symbol which we use for real number is r. Now let's look at our problem. The problem which we have is if n is equal to n times n plus 1 times n plus 2 times n plus 3 plus 1, we want to see if it is divisible by 25 or not. Like I said, when I first looked at that, I said, how in the world I'm going to relate this to 25? I don't know what is n. What I'm going to do in here, the first observation which I have, 25 is equal to 5 squared, so it's a complete square. Then the first thing come to my mind is it possible that I write Fn as a complete square or not? I need to use a trick to make it complete square, because if I make it complete square, the problem can be solved easier. So to make that a complete square, let's look at this thing right here. If I multiply, I wrote this n and n plus 3 red and these two black, meaning that multiply these two and multiply these two. Why did I select this? Remember, I want to make it complete square. So if I multiply n and n plus 3, I create n plus 3n. And if I multiply this by this from FOIL, I'm sure all of you familiar with the FOIL, like first, last, inner, and outer, stand for void. N plus 3 will be created. So I'm going to multiply them, and if I multiply them, I'm going to have something like this. As you can see, this term and this term are similar. So what I'm going to do, I'm going to call this x. And then if you multiply x times x plus 2 plus 1, we are going to have a term such as this one. Hey, this is a complete square, x plus 1 square. Now, it looks like we hit the jackpot. So instead of x, I'm going to write down n2 plus 3n plus 1. So my fn really changed to this. Then after that problem would be very easy, because in the problem says that how many natural number less than 1000 exist that fn is divided by 25. So in here my fn changed to this. So this term has to be divisible by 25. If this term wants to be divisible by 25, that means inside the principal parentheses must be divisible by 5. n2 plus 3n plus 1 must be divisible by 5. Now still the problem is not as straightforward as it should be to be able to answer it, but it become a little simpler. So in here, I'm going to argue that if n2 plus 3n plus 1 is divisible by 5, then I will have n2 plus 3n plus 1 minus 5n has to be divisible by 5 also, because naturally 5n is divisible by 5. So if we subtract this from n2 plus 3n plus 1, that must be divisible by 5 as well. But the good news is, if you look at this, if you do some mathematical manipulation, this is going to turn to n2 minus 2n plus 1. Notice that 3n minus 5n is minus 2n. And hey, again, it became a complete square, n minus 1 square. Then in here, I will argue that if n minus 1 square is divisible by 5, n must be divisible by 5. Otherwise, it is impossible that n minus 1 square is divisible by 5, but n minus 1 is not. So I should be able to write n minus 1 square, n minus 1 as 5k. If I write n minus 1 as 5k, my n is going to be 5k plus 1. Now, I know that my n is between 1 and 1000. So that means, since n is 5k plus 1, 5k plus 1 is between 1 and 1000, or between 0 and 999. As a result, my k actually, I apologize, I wrote 5k. This should be k, should be between 0 and 199.8, or k would be 200. So there are 200 numbers that are divisible by 25 in that equation which I gave you at the beginning. If you like our video and enjoyed it, please don't forget to subscribe our channel and hit the bell button and like as well. That can help us to put more video for us, more video in our channel, and at the same time, when we put a new video, you'll be able to see that first. Thank you very much for watching our video, and I wish all of you pass the Olympiad exam, no matter which country you are taking that.